Welcome everyone to today's training. We'll be talking about dealing with A-zones today. And before we start introductions, just a couple of logistics. We are using the chat and we'll be trying to watch questions in the chat. If it's something more time sensitive with what we're talking about, we'll address that right away. And some of the questions we may save to the end. Also, common question we get is whether we'll be sharing recordings or sharing the slides. We will PDF the slides and share those with everybody who registered. And we are recording. Eventually, probably be a month or so, we'll get this posted via our website. Again, welcome to our virtual training on dealing with A-zones. I'm Ceil Strauss. I'm the State Floodplain Manager in Minnesota, and I'm joined by Jeff. And Jeff, take it over.
Hi, everybody. My name is Jeff Weiss. I'm a floodplain engineer working alongside Ceil and Gary. I help work with the technical side with the modeling and mapping portion of things, so do a lot of coordination with Ceil and Gary as we work with floodplains around the state. Today, we're going to cover a number of different topics. Some things will be referenced early in the presentation to then be discussed later on in the presentation. So we're going to do an overview of what are A-zones. We're going to work on some terms and definitions and regulatory overview, give you some updates on the FEMA map update process, what data we have and when it's going to be available, get into administering A-zones, where to find A-zone based flood elevations, and then looking at floodways versus flood fringe in A-zones. That's something that comes up on a somewhat regular basis. There are multiple different types of floodplains shown on FEMA maps. The most common ones that you will find are zone AEs and zone As. Sometimes there's zone Ds and zone Bs and VEs for the first time in Minnesota here in about a month and a half. But zone AEs and zone As are by far the most common, and we're going to be concentrating on the zone As here. Zone As are referred to as approximate studies. So usually there's very little to no fieldwork completed to update these studies. Historically, these floodplains were just estimated on the maps. Now, in those older firms, those maps might have been referred to as flood hazard boundary layer maps or just flood-prone quadrangle maps from USGS. But newer maps, newer D firms, do have models and other supporting documentation to help estimate these base flood elevations within the map. So base flood elevations, as we get into a little bit later, is also a synonym for, say, the 100-year flood elevation or the 1% annual chance flood elevation. So this base flood elevation is going to be a term that we will be using repeatedly throughout this presentation. But anyway, most of these newer D firms, digital flood insurance rate maps, do have models and other supporting documentation behind them, which is really, really helpful for administering these Zone A regulations in your neck of the woods. And as you can see on this map, there are the blue lines are all the zone A's around the state. So the vast majority of the floodplains around the state are there's blue lines around the state. The red lines are zone AE areas. Those are generally concentrated on major streams or highly developed areas like the Twin Cities or Rochester or things like that. Older zone A's looked like this. On the right side is the oldest version with kind of a dot matrix printout, and the left side is slightly newer versions. But the main point on these two slides is that there are not aerial photos behind these. So you might see an approximate or see this delineation on the map, but it's kind of a best guess what that really means to your landscape. So the improvements with these newer maps that are being shown, that are being developed now, these zone A's are being shown on top of aerial photos. So you can really see that delineation right next to roads, buildings in your communities. And the other great advantage with these newer maps is they're being mapped with newer LiDAR. And so the edges of these floodplains are going to be fairly accurate compared to the models that were used to develop them. So it's a great improvement compared to historical maps. In contrast, Zone AE maps do show a lot more information. Zone AE areas are usually referred to as detailed studies, and since it's more detailed, they have more detail they can show on the maps. So they'll still show the same light blue overlay for the edges of that 1% annual chance floodplain. But then there's also the red and blue hatched area that shows the floodway, and we'll get into the floodway here in just a moment in the next couple of slides. But then it also shows the kind of orangish medium flood risk that's often thought of as like the 500-year floodplain, or 0.2%. Then of course there's the areas that are low flood risk that are above that elevation as well. So to look at the floodway here a little bit, we're going to show the floodway a couple different ways. The floodway is generally a spot in the floodplain where the water is going to be deepest and moving the fastest through there. So usually your main channel is going to be right in the middle of the floodway, or at least on the edge of it. And then your flood fringe is going to be where the water is shallower or not moving nearly as much. It's usually on the edges of your floodplain. So to show that in a cross section on this next slide, you can see again that floodway is right over the stream. You can see in the slide the water is the deepest there. But if you look over, especially on the left side there, the flood fringe, you see that water is a lot more shallower. You're going to end up having structures and trees and things like that in the way there. That's going to be slowing the water down. But it's still floodplain, but it's referred to as flood fringe. When we model a floodway, we actually try to simulate that flood fringe being filled in. So these simulated encroachments are kind of simulating filling in that whole flood fringe until we get to a floodway. It makes sense that if you fill in that flood fringe area, you're going to end up raising some flood levels on the floodplain, because you're taking away flow area, and that's going to cause water elevations to go up. Minnesota rules say that you can only increase that flood elevation by 0.5 feet. We refer to that increase as a surcharge. We say maximum of half a foot of increase is allowed in that type of a floodway situation. But there's an important caveat there, as Ceil is underlining there. That's as long as there's no increase of flood damage potential. And we interpret that as meaning no buildings can be adversely impacted. So if there's a structure that's right on the edge of the floodplain, you cannot put that structure in the floodplain by increasing that surcharge and then making them have an increased flood risk. Or if they're already in a floodplain, you can't increase that flood risk on that building. You can't increase that level on that building that's already there. The flood insurance studies that are available for counties, for most counties across the state, there are a few counties that don't have flood insurance studies yet, but the flood insurance studies that are available for your communities have a lot of detailed information about all the studies that happen in the county or in the community. It gives us a lot of detailed information about what methods were being used, and then for floodways and things like that, they include these tables called the floodway data table on the right side, where it gives you elevations and surcharges that have been found for the different cross sections that are along the river for your going through your area. This is a generic one from Floodville, California, or something like that, but it's something that's used from like CFM exams and things like that. As we mentioned before, a lot of the newer digital flood insurance rate maps have models that are underlying those floodplains. And because they have models underlying them, there are cross sections that were used to develop those elevations, to develop those floodplains. And with some of the online viewers we have, or the main online viewer that we use is called Lake and Flood Elevations Online, and we have some links to it later in the presentation. We're able to use the cross sections from those models and show them on that viewer, and then show the elevations for the model on that viewer as well. On that viewer Lake and Flood Elevations line, we show those lines as pink, so we refer to them as pink lines. I'm going through here. So you can see here, these two cross sections, the one elevation there was right at 1,000 feet. The other one just upstream to the south is 1,000.3 feet for that particular one. And this is super helpful for regulating and managing floodplains in your area, because it is important to have elevations for these Zone A areas. And we'll get into that in these next couple of slides here. It's important to have elevations for both Zone A's and Zone AEs without floodway, because it's important that if a structure is going to be proposed on the edge of that floodplain, we understand if that structure is going to be built at the appropriate elevation. So you're not allowed to have new structures in a floodplain unless it's being shown as being flood fringe. So it has to be we have to show that the structure is not being proposed in the floodway. And if there's any development, whether it's grading, culverts, or bridges, we have to show that development is not going to cause an increase in the flood elevation by more than the allowable rise, which is defined as 0.5 feet, and also make sure that there's no adverse impact to existing structures. So having these elevations on the pink lines makes it much more useful for understanding what potential impacts there will be for proposed development, and gives you a baseline of comparison for that development for when it comes in. And we'll get into some of those examples here as well. This slide includes a lot of the same information I just tried talking through, but it's a lot of words that's not necessarily useful in presentation, but it's a great resource for you when the slides are distributed, and there's a link here for the Minnesota Floodplain Management Quick Guide. This is another spot to look at why or when it's important to understand that lowest floor elevation requirement. So we have the Minnesota Regulatory Flood Protection Elevation, or the RFPE, which is the minimum lowest floor elevation for a new structure being constructed adjacent to a floodplain. So you're going to take your 100-year flood elevation, your BFE, or your 1% annual chance BFE. You're going to add your stage increase due to the floodway or flood fringe there, and then you have to add a minimum of 1 foot of freeboard. Your community may opt to have a higher freeboard requirement, but the state minimum is at 1 foot of freeboard. So that's going to end up giving you your regulatory flood protection elevation for that new structure. And this slide helps illustrate how that plays out. So you see the 3 dotted lines going horizontally across the stream here, and the middle dotted line coming across is the 1% BFE. So you can see that this is a situation where somebody wants to build at the edge of the floodway or floodplain, and they're going to create some fill. They're going to bring in some fill to elevate their structure. So they need to understand what that elevation is there. They need to understand how much fill is needed to be brought in to bring that regulatory flood protection elevation high enough above that, above the BFE for that stream. And there's other important things in this slide too. For instance, there's a 15-foot setback from the edges of the new floodplain, and this also shows that this has to be in the flood fringe rather than in the floodway itself. You can see that on the bottom of the slide as well. So this is a great reference slide for the future to understand kind of how all this fits in when a structure is being proposed at the edge of the floodplain.
I'll just mention that the 15-foot is for residential structures. They're required to have the fill at a certain elevation within 15 feet of the building. And that'll be in addition to setbacks from the ordinary high if you've got shoreline regs.
We're constantly trying to update maps around the state. We're trying to give you the best available data, and we work with FEMA to try to figure out which counties, which areas to study next to bring the most updated data to you all. So we do have a resource online that helps you see the status of different counties. And so this slide just kind of gives a link to where you can find that link. It's not always exactly up to date, but we do update it, fairly regularly, try to bring things up to date. So you can see, the kind of blue-purple counties, those all have DFIRM counties. Those all have digital flood maps. The green counties still have old paper maps, but most of those counties, you can see a lot of green on that map, but most of those green counties are either in the process of being updated or just about to have new effective maps. I think it's possible that this particular slide is just a little bit old, because I think a couple of these counties have gone through. There we go. This is the updated version. So you see there's a lot less green in this map. You can see that all those smiley faces shows that where there have been new DFIRMs in the last year and a half or so since the end of 2023. So maybe a little bit less than a year and a half. And you see these other counties with little asterisks on them. Those are already funded through, they already have preliminary DFIRMs available. There might be some revisions that are going on through some of those. So there's a lot of work that's being done around the state to try to update these counties into better data. Also, you can note on this slide, you can see all of the kind of the pink squiggly lines. Those are all the stream lines where we do have the pink lines available online. So in the legend there, it says the estimated 1% base flood elevations. Those are available for all Zone A areas in those counties. If you happen to be in a county that doesn't have that being shown there, it doesn't mean that there's not data available for that. It just might mean that it takes a little more effort to get to it. But the good news is if your county does have those pink lines on there, then those pink lines should be available on our viewer online. Like I said, we're constantly working around the state trying to update different things. And these next couple of slides we'll go through very quickly, just trying to give you an idea of where we have been doing studies over the last almost 10 years or so. So even if some of these areas have not gone all the way through having updated maps, there are newer data available that is helpful for regulating the floodplains at your local level. So a lot of these areas might mean that there's better available data or new best available data that might be better data than would be available on the official FEMA maps. So these are the different watershed studies, or the previous slide is the different watershed studies we've done since about 2016. Next slide is we're looking at, FEMA has a process where they do discoveries around the state. So these are the active discovery areas that we're doing. So discovery is the first step in the FEMA update process. So we're looking at both northeast and northwest areas of the state, either watershed studies or countywide studies. The next slide we should have, we're looking here in the Twin Cities. We're currently updating a lot of the modeling and mapping around the Twin Cities metro area, including the Twin Cities Huck 8. And then we're also updating Anoka County outside of the Twin Cities Huck 8. So we're kind of doing it a couple different ways here, but the studies here in the metro area are getting old as they are around other parts of the state. Next slide is we're looking at, there are several counties that we have preliminary maps available. There's preliminary maps that are either moving forward or they're available and they're actually moving towards getting them finalized. So Anoka, Chippewa, Murray, and Rock County are current counties. There's another county I realized that we left off here. Winona County down on the southeast corner is another one that has prelim maps available. FEMA's contractor is working through that one. It's that's still a few years off, but anyway, that's another county that's in process that we accidentally left off of the slide.
They're in the works. They don't have anything showing yet either.
And we also sometimes work with FEMA to create better data LOMRs, meaning we're completing a letter of map revision based on better data. We have completed a couple of those already, and the ones we have currently underway are in Rainy River and Kootenai County and the Cedar River watershed down in Dodge County. This includes a link to the estimated map status. So this is a spreadsheet that's updated probably close to monthly, at least, so it's fairly up to date. And this provides summaries of when maps were updated and also when things are estimated to be updated. So if you're looking very quickly here, you can see Chippewa in the middle of it. It includes an estimated map effective date of 2025. So we include things like that when we think things are going to be updated, even if we don't have exact dates yet. And I think this is where Ceil takes over.
Yes. So we're going to talk a little bit about what BFE sources we do have, those base flood elevations or 100-year flood elevations. And we'll talk a little bit about what's available through our lake and flood elevations online site, county data viewers. We'll talk a little bit about our shoreland method that you can use if you've got a lake, and a couple other sources of information we have to get better data in those A zones. So we've already mentioned our pink lines. I know that we've talked about our lake and flood elevations online viewer in many of our other trainings. And if you're not already familiar with this site, it'd be a great one to get to be familiar with. But one of the layers that we do have here is the estimated 1% water surface elevations. We purposely don't call them estimated BFEs because that's the official elevations. But FEMA does accept us using these water surface elevations, the 1% water surface elevations, as best available data for the base flood elevations. So here's an example where we've got an unmodernized map, and here's another example showing the same things, but on one of the newer DFIRM counties. And unfortunately, it must be one of the DFIRM counties. Yeah, it is. It looks like it's in Benton County. And it was done before we had as much LiDAR backing, and they didn't delineate along the contours based on LiDAR, you can see here. But we did have some supporting models and have at the cross sections, these can be used as best available data. And if you're between a site, you can always take that upstream elevation, and that's a good estimate for your BFE. Okay, there we go, showing the symbology here. A couple more words about getting the pink lines. You can get that layer at the Mingeo Commons if you'd like to have that on your own GIS systems. And as we've mentioned, it's on Lake and Flood Elevations Online. We've had it on there since 21, so people are getting pretty used to it. And if you saw that there was work going on in those other counties and those other Huck 8s, if you don't see pink lines in those areas and you're looking for some data, that's when you can ask DNR floodplain program staff if we have any data that's been done, that's been developed. It may or may not be through the full review process, may put some caveats on it, but we may have some additional data available that can be used as your best available data. For some counties, we do have some other viewers. And this site here It will link you to preliminary new maps or the pending maps, and sometimes it'll link you to a work map layer. Those are more hit and miss, but usually there's one or two counties in the state where we've got a kind of a work map layer that you can use. I think right now Winona's got one. Switching into a little bit different system is our shoreland method. In Minnesota, of course, we have many lakes, and what we did many years ago was work with FEMA to get agreement that we could use what we call our shoreland method as best available data on lakes when we've got enough data. And this is based on the idea that in the shoreland district, we've got wording that says, hey, if you've got a flood elevation, you use the regulatory flood protection elevation that is in your floodplain ordinance, or that would be in a floodplain ordinance if you had one in that community. Otherwise, within 1,000 feet of lakes, you still need to come up with minimum elevations that are safer for those buildings. So the shoreland rules say, okay, if you don't have a flood elevation and you're not just adding your freeboard and using the regulatory flood protection elevation, you use 3 feet above the ordinary high or the highest known water level, whichever is higher. We do have, actually we've got a page in our quick guide showing that same concept here, that if the flood study is available, lowest floor's got to be at the regulatory flood protection elevation. And for lakes, you don't usually have a stage increase unless it's part of a lake system or a river system. So it's usually the base flood elevation plus a foot of freeboard minimum. But if you don't have that, again, 3 feet above the ordinary high or the highest known water level. Here's another way of looking at that. So the concept is that, gee, if we're saying the lowest floor elevation using the shoreland method is 3 feet above the ordinary high or highest known, and consider a foot of that to be our mandatory freeboard in the regulatory flood protection elevation, that means that 2 feet above the ordinary high or highest known is a reasonable estimate in Minnesota on lakes for the base flood elevation. And this works if you've got enough data on that lake. You've got a good history of water levels. It's a lake that has an outlet. It's not a landlocked lake, and some other things like that. So to see some of that information, you can go to Lake Finders, see the water level information. But now you can also see it in our lake and flood elevations online application. If you click around on the lakes, if it is a lake that's got a detailed study area, you'll see the flood elevations available for that lake and in detailed studies for sure. But then, and you can, if you hit this little docking thing here, it'll put it off to the side so you can still see your site you're looking at. And if you scroll down, we now have the ordinary high and highest recorded elevations and the date of the highest recorded for both the lakes that have FEMA flood information and on many lakes where we don't have the flood elevations on this call out window, but we'll have the ordinary high and the highest recorded. So you can go here and find that information in addition to looking on Lake Finder. So we do have an info sheet about this that kind of summarizes what I just was talking about. And FEMA, for letters of map change for LOMAs, LOMA-REFs, they have been accepting this method for decades, actually. It's very helpful throughout Minnesota. Another source of information for A-zones is, has there been a letter of map amendment or letter of map revision based on fill done? The older ones do show the base flood elevation right on that determination document. And newer ones, starting probably 10, 15 years ago, FEMA, for whatever reason, stopped showing the BFEs on there, but they still show the lowest adjacent grade. So you know if the lowest adjacent grade, they got a successful LOMA, you know that the BFE they're using was that elevation or something lower. If you want to know what BFE FEMA was using, DNR staff, we can get copies of the background information for those LOMAs, and we can look through and see what they used as the BFE usually. So one nice way to look at it is on a couple of FEMA's viewers. The FEMA National Flood Hazard Layer viewer is a really nice one to look at that, because you can go and look at it. If you click on that dot, you will get a little box like this, and you can check what the address is, see where that's located. The more recent ones, the dots are going to be pretty close to where the site is, where the building is. Older ones, it might be in the vicinity, because those older ones, they didn't geo-reference as well. But you can download a copy of the determination document. And again, on some of the older ones, it'll actually show you what the base flood elevation is, or you can look at that lowest adjacent grade. So this can be really helpful in getting base flood elevations in some of those A zones, especially areas where we don't have the pink lines. Or maybe it's an A zone that's more of a basin area, it's not a flowing watercourse area. Other places that we certainly look is, does the city or the watershed district have some modeling? Many of our watersheds and communities do have some better data. You can contact the DNR area hydrologist or our floodplain staff if you reach out to our floodplain.dnr@state.mn.us. There's several of us that see that email, and you can request help. The other thing to be aware of is that you can apply for a letter of map amendment. And if you've asked the state, you've checked and your city or the watershed doesn't have any data, you can ask the FEMA reviewers to determine the BFE for a site. That's only good if it's a one lot type of situation, not for a whole subdivision, but that can be helpful. Sometimes we'll look at bridge information in the area, either that DOT has or that we've got from permits in the area, that DNR permits. And kind of last gasp type of estimates would be contour interpolation, and using that. That's not always so great. We'll look at whatever sources we have. If it's not one of these other things we've talked about, it's not available there. In a nutshell here, if you have provided homeowner with the best available data that you could find for that house, and it's in an A zone, must they accept your determination, or can they hire an engineer surveyor on their own? If we were in person, I'd be looking at hands or whatever, but let's just look here at the answer. That is fiction, that you're helping them out, but helping them find the best available data, getting DNR assistance with that. They can always choose to bring in an engineer to do a more detailed study, but it will be on their dime. And Jeff, I think we're turning back over to you. A reminder that in addition to A zones, there's AE zones. There's detailed areas where we don't have a floodway. For the regulatory purposes, we're pretty much treating them the same. And in our model ordinance, we do, if it's not floodway or flood fringe on the current map, we call it the general floodplain. So that is both the A zones where we don't have any information, or the detailed study where there might be the cross sections and base flood elevation lines, but there's not a floodway determined. So in general, we say from a regulatory standpoint that if there's not a floodway delineated, we're treating the entire floodplain as floodway. So they can't put any new buildings in there, and they do need to look at allowable rise and look at whether they're able to do the project they want to do. Then if they do want to determine if it's floodway versus flood fringe, they can do that. And then once that's been determined, the floodway area will be treated as floodway, and the area that you've newly determined to be flood fringe can meet the flood fringe requirements. So again, first option, treat as the whole thing as floodway. Second, you get some better data on where's the floodway versus flood fringe. If you haven't already figured out the BFE, that's going to be part of the process. And For instance, in some of these areas, we do have the mapped floodplain. We'll be showing some areas that are actually above the BFE as part of the floodplain, and it's not following the contours. It was done earlier before we were using all the LiDAR. So if the mapped area is above the BFE, it's treated as flood fringe. And if it's within the FEMA mapped area, you're still regulating it, but they're going to be allowed to put buildings there. They would still need to make sure they're meeting the minimum elevations, but it's an easier process. If it's below the BFE, you've got to figure out where that floodway location is. So here's another way of looking at, again, you can treat the whole area as floodway and just say we're keeping the buildings out of there. If it's outside of the area or above the BFE, then it's a flood fringe area, and if it's shown within the mapped area or if it's within a shoreland area, you're still going to require the minimum elevations, but you've got the BFE to work with. And that's actually repetitious, but this is a good example showing an example where that spot there is clearly above the BFE. It's a place where you can see the boundary is not following the contours. So you can say it is flood fringe in that situation. Then a reminder that if it is a bigger development, if it's got 50 lots or it's a 5-acre, say, commercial development or something, the federal requirements do say you need to do a detailed study. But then, so you've got that. And then if you do want to, if it's an area where we can't use some methods that we'll be talking about a little later, you're going to hire an engineer to figure out where the floodway versus the flood fringe are. And we'll talk about some other methods a little bit later. So I think this is where Jeff starts.
Yep. I'll take over from here. So this still goes hand in hand with the previous slide too, as far as if there's a proposed development of 50 lots or 5 acres, like Ceil had shown in that slide, the federal requirements do require that it be a detailed study, or at least detailed methods study, even if the final map change remains a zone A. So to do a detailed study method, you do have to determine a floodway. We're not going to get into the details exactly how to do a floodway in here. I know a lot of folks, even on this call, are seasoned veterans of putting in a floodway, but some folks maybe have only been through it a time or two, or might need some guidance. I know we definitely do help folks understand what they need to do to put in a floodway if they do have questions. But they'll take that existing zone A models and create a new model for that area, and they'll add a floodway to that model, and then they have to make sure that there's not a stage increase more than half a foot. It has to be half a foot or less. And always the caveat there: no increased flood risk on any insurable structures that are already in floodway or adjacent to it. And then for the documentation they would need to prepare for the LOMAR, they have to show where that floodway would be, and they have to include verification that the impacts are within that allowable rise before everything is approved at the local level. And then for you, you'll need to keep all this information with your records locally, and we keep copies of things too. So next slide is talking about, if you have a model back zone A, now what do you do? As we kind of talked about on the previous slides, there's definitely times where the contours may not match elevations, as the one slide Ceil is showing. And then we also have a situation here where there's a huge water surface drop across the stream. So the water's flowing from south to north in this slide. And I know in a later slide we have zoomed in on the elevations here, but that's a few slides down, so we won't jump at that quite yet. But this one happens to show like a 7-foot drop across this road, and everybody on the slide knows that that's not typical. So with these zone A models, as we tried to explain at the beginning, there is a lot of approximate methods that are put into these models. So therefore, it's missing some detail. Sometimes models are missing a lot of detail, like what's being shown on here, where this is just kind of a geometric shape here, where it's just flat, flat slopes, things like that. This doesn't really represent the landscape unless this is on a freshly graded development in your community. But some models do look like that. And then other times there are models where a lot of these zone A models are only using the available LiDAR, and LiDAR can't penetrate water surface elevations. So that LiDAR is only going to grab the top of the water surface elevation of the stream. It might be missing the deeper part of the channel. So So sometimes that channel can be fairly deep, but it might be a fairly deep, narrow channel that's just being missed, and you're missing a lot of conveyance through there. So, so sometimes if you're adding then these details, adding in more channel information, or just making the shape look a lot more like what your valley cross section looks like, that can change the results fairly dramatically. Next slide. So this is a slide showing that 7-foot drop across this crossing here. And there are a number of different things that we can do to try to figure out if that's real. So there might be a common situation is there might be a homeowner just upstream of this crossing that wants to show that they're really not in the same risk as what the floodplain maps are showing. So therefore, we want to go in and update the models here to try to show that the risk isn't that high up there. So we can go in and update. You can add in some of that survey data like we're showing before. You can add in survey data in the channel to show more conveyance in the cross section. And then also sometimes you need to open up the model itself and make sure that the bridge is modeled correctly. Sometimes the bridge or culvert isn't really modeled directly at all, and that's causing that big difference. Sometimes the culvert might be underestimated. The real culvert might be, say, something like an 8-foot culvert, but somebody just looked in the aerial photos and they thought it was only a 6-foot culvert, and that can have a big increase or a big change on those flood elevations. So those are kind of some of the main things you can do right away there. So to be able to get the models to look at these areas, especially if they have those pink lines available on LFEO, those models are generally going to be available on our model download site. So there's a link on this slide to that download site. I know a lot of our veterans in accessing data from that. I want to point out the fact that there are models that we have that are not linked on that site. We're slowly but surely trying to get everything up there. Most stuff that's not up there is going to be older models that maybe aren't geo-referenced, and they're just kind of harder. Takes longer to link where they are, but the link to the hyperlink in the bottom generally shows where there's model availability. And also, one other thing I want to point out here as well is if there's a stream on that download site and it says that there's not a model available, we also say please contact us to figure out if there's something that might be available. So these gray lines indicate that maybe the model's just not uploaded yet. All the blue lines are going to have models that can be downloaded directly from the site. The gray lines, it may just be that it's not available on the site, but the model may exist. And we do have a new email address to submit a request for these models. So every once in a while we don't have the model. That definitely does happen, but more often than not, we can find a model available if it's a gray line. And when I'm done talking, I'll put in the email address for that newer website as well. I'm not going to rattle it off the top of my head here because I'm afraid I'm going to say something wrong with it. But when you get into that website, you can see there's a lot of great information. If you click on that blue line, it'll show you what model was used for it, when the effective date was for it, and then there's a download link for it as well. There's another table that tells you, who did it, the source for the mapping, and things like that. So there's a lot of good information on there. Every once in a while, we have models that, as models get updated, we have the newer models and the older models available because sometimes those older models can be really helpful to understanding maybe how something got modeled or mapped in the first place. But usually, in most situations, the newer model that's available is going to be the one that's going to be the actual effective model versus the older model in those situations. But sometimes those older models are helpful for historical context. We talked earlier about the fact that encroachments in a floodway cannot create a stage increase more than 1/2 foot at any point. Shoot, I'm kind of forgetting what else we were going to talk about in this one. Ceil, do you remember?
Oh, just pointing out that in addition to working with a professional engineer, we've got some situations we're going to talk about where we can use what we consider standard engineering practices.
Right, thank you. And yeah, that segues into the next slides, that's right. So when we're talking about these alternative methods for estimating a floodway, this is when we can make the judgment call that the situation is clearly a backwater situation where you won't have velocities or really any flow going through that part of the slide, or through that part of the floodplain. So this is often might be immediately upstream or downstream of a bridge, and we'll show an example of what that looks like, and also might show like on lakes or other basins where it's really you're looking at the still water elevation for the lake rather than a flow through area for a floodplain. And those are going to be covered on your local shoreline ordinance as well. So in this situation here, the orangest area is the floodplain that's being mapped for this stream. So you can see this proposed site is on this kind of lobe of floodplain that's located north of this particular stream. So you can see, since water can, technically get up there, but it can't flow. It can only flow in and out in one spot. So therefore, there's no water really flowing through that site. That means it's going to be an ineffective flow area, meaning there's not water, there's no velocity going through there. So this is a spot where we can say there is no floodway here because there's no velocity in this particular situation. So you wouldn't necessarily need to do additional modeling to show that that it's not the floodway, because it's something that can make a logical judgment call that it's not actually the floodway in this particular site. But these next couple examples are a little bit less clear. So this first example, we show a proposed structure, and we can see that the top call out here shows the 1048 contour going through that site. And you can look at the elevations being shown on the pink lines there, and you can see that the elevations, the highest elevation near that proposed site is 1047.6. So you can see that structure, that proposed structure is already out above the flood elevation for this particular stream. They're still going to need to elevate a little bit more to get to their RFPE, but the site itself is already outside of the main floodplain and therefore not in the floodway itself. So therefore, you don't need to make an additional determination on the floodway. However, the second site is now located inside, or maybe on top of, that 1048 contour. So some of that site is going to be inside that contour, and then now it becomes a lot less clear of whether or not that site is actually above that flood elevation, or if it might be below. And then you might need to do a little bit of additional work to make sure that that is not the floodway. So for instance, here, if you draw a line, that red line that popped up there shows that kind of line in between, kind of connecting the 1048 contour there. If that proposed structure is located inside that 1048 structure, that 1047.6 cross section, that might be touching on that structure, and you might need to do some additional work to make sure that's not the floodway and that it is actually the flood fringe. That's the main point of those two slides there. And this next couple of slides show the impact of ineffective flow areas adjacent to bridges. So if you have a bridge opening, flow has to kind of constrict to get down to the bridge opening, and then once it gets out of the bridge, it actually expands to get out to the full floodplain. So those kind of triangles just upstream and downstream of those bridges, they end up being ineffective flow areas where there's really not much velocities going through there much at all. So those are typically not part of the floodway because there's no velocity going through there. But these areas do get a little more tricky. So a couple more examples here. We can see this proposed site kind of up in the top part of this lobe. You can kind of see that looking at those calls before, if you look at those triangles, that area is still going to be outside the effective flow area. So usually coming into a bridge, the rule of thumb is that you use about a 1-to-1 ratio for flow contraction coming into the bridge, meaning if your floodplain is 100 feet wide, if you're 100 feet upstream, then that floodplain is going to be fully expanded. And then kind of similar on the downstream side, flow actually expands at a slower than it contracts. So the rule of thumb we use for flow expansion is that you use about a 2-to-1 or 3-to-1 ratio coming downstream of the bridge. So you have to use some judgment call about whether or not these sites are still going to be inside or outside the floodway or floodplain. And both of these, just using these rules of thumb, these proposed sites look like they're both outside of the floodway, but it's still something that's good to be better safe than sorry, and maybe ask the proposer to show things a little bit more clearly than judgment calls in these ones.
Hey, Jeff, we had a comment in the chat that only applies if you don't have a lot of water going over the road, or the majority of the flows are going through that culvert crossing or that bridge crossing.
That is an excellent point. That is a very excellent point. Thanks for that clarification there. That's yes, it only applies if all the water is going through the bridge. But if you have water going over the bridge, then those expansions and contractions are not relevant to that bridge opening anymore, or you need to make some additional judgment call to make sure you understand where that velocity risk is.
Yeah, and I think I take over at the next slide, but this is an example of one where working with the DNR staff to get another pair of eyes and make sure that we're both seeing the same thing, and for instance, verifying that you don't have water going over the road, and that this is effective option to use at that particular site. Talking about lakes, we do, in a typical lake situation, Like on this lake here, you might have a main outlet, you might have a couple tributaries, but most of the lake on your typical big lakes, it's really more of a backwater. As water comes in, the lake might go up and down, but you don't have flow on the edges of most of the lake. In this situation, this is a lake that is obviously in a riverine system. And think about Lake Pepin on Mississippi River, that, or there's many places like this in the state where, yeah, it shows up as a lake and in our Alfeo site, but it's really part of that river system. So we would have to treat that as a flowing area. Here's another example, Medicine Lake here, where most of the lake, you're not going to have flows at the edges of the lake. But if you're near an inlet or an outlet, you do have to look at those separately. And I get at this because in our optional wording in our sample ordinance, we say, if it's your typical lake and you aren't near an area of flowing, we consider below the ordinary high to be the floodway and above the ordinary high to be able to be treated as flood fringe. So that helps you with administering a lot of areas in Minnesota because so many of our flooding sources are lakes. And again, we do have some language in our model ordinance that basically says, yeah, if it's not impacted by velocities, not part of a watercourse system, that as long as you're limiting what's happening in that shore impact area, you're limiting what's being done. You're just doing some erosion control or maybe some stairs or a path, but you're not doing a lot of filling in that area. Then you can use this approach of saying below the ordinary high can be treated as floodway and above can be treated as flood fringe. Because we're assuming too that you're meeting applicable site setbacks and you're not doing a ton of fill in that area right next to the lake. Reservoir system, boy, that's a good question. I'd have to look at the situation, but on much of the reservoir system, you're not going to have the flow. So it's going to depend on where you are in that system, I think. We'd have to look at that site by site there, Henry. So moving on to some other data that we have in A-zones. For the detailed study areas, the older studies, in addition to that 1% annual chance, the BFE, the 100-year, they modeled the 10-year, the 50-year, and the 500-year. And in more recent studies, they started adding in the 25-year or the 4% annual chance and something called the 100-year plus. And many of our A-zone models, they started doing those other frequencies also. So in many cases, and I'm going to go to a map that shows the counties in the state where we have other frequencies in the A-zone models. So you can see here, we've got quite a few counties in the state where they didn't just calculate the 1% water surface elevation that we're showing in the pink lines, but they also calculated typically the 10-year, the 50-year, and the 500-year. And then some of the more recent ones, they've got that 25-year and what we call the 1% plus. This is showing that we've got the data for the effective maps, or soon to be effective, for Itasca and St. Louis. And the yellow ones here we had that data in the preliminary maps. And so you've got that as best available data. And we have that currently as shapefiles that we've done combined shapefiles that put that information together. So here's an example in a GIS layer here. I've loaded this, this layer. And let's say I wanted to look at, I needed the 10-year. I wanted to be looking at putting in a septic system. And our state rule says, if we know the 10-year, we're supposed to be putting these things above that. So I go here in the table in my GIS, I can see the 10-year flood elevation. And we're working on getting this information into one of the layers that we've got available, and then making it a layer that could be on our lake and flood elevations online to make this a little bit more accessible. But I know I've shared those files with a few counties, but if you're a county that you haven't got those files, we'd be happy to share those with you. Internally, you can certainly be using that. Again, it's really helpful for looking at those other frequencies that you might need for other purposes. Or if you want to have higher standards, you want to know what that 500 year is because you're putting in some critical facilities and you want to make sure you're outside even the 500 year for those facilities you want to make sure aren't getting damaged during times of flooding. So ending here with just a couple slides with some resources. As I mentioned at the beginning, we will take our slides and PDF them and share those with everybody who attended or registered. And so you can use the links to these sites. And we've got a link to our quick guide. Did we have any other questions that came up?
Chat, I think we got those.
Okay. Yeah, and the 1% plus, I didn't want to run out of time here, but I will mention that is something that when you're doing estimates, you're trying to get an idea of what the flows are for those different frequencies. They're basically looking at a range of possible flows. And for most of the modeling, we're taking the middle of that range. So that 1% plus is looking at that upper side of the confidence level, as Jeff wrote in there, that it's, I believe, the 95% confidence level. And we haven't done a lot of looking at comparing it to, say, the 500 year, but that's something that we're seeing as a possible source of information to look at future protections.
I'll add on just a little bit there, Ceil. I was realizing I maybe chose some inexact language in the quick comment there because it's kind of the 95% confidence interval, but it's also it takes into account standard error related to estimating those flows. So for instance, if you use regression equations from the USGS, those equations come with the standard error. So that 1% plus includes the maximum error that might be associated with those flows. So it's probably another way of saying 95% confidence interval, but it's and maybe I'm diving too far into the weeds there, but sometimes that 1% plus is more than the 500-year flow, but sometimes it's less. It just depends on the stream. It's just kind of, sometimes it's more, sometimes it's less.
And I think that's the last slide.